Most students lose marks on this kind of questions not because they don't understand logic, but because they misunderstand what 0 and 1 truly means. Now, in this video, I'll show you exactly the trap that Cambridge set for students in this computer science paper 2 of the May-June 2025. Welcome back to my channel. My name is Uche Namdi Nicholas. I am a computer science and ICT teacher. Are you ready? Let's do it. So this is question number 8 of May-June 2025 computer science paper 2 that is the Cambridge IGCSE. So here the question number 8a says draw the symbol for an exclusive OR logic gate and complete the truth table for it. So this is the space for the symbol. So this very logic gate looks like an OR gate, but with the sign of exclusivity. Yeah, something like that. Okay. All right, good. So I'm just using my touchpad here to draw this. Let me make this a bit finer. So here we need to complete the truth table. For the exclusive OR gate with two inputs, this is how I simply look at it for quick understanding. What I do is that I'll just check if they are the same, if both inputs are the same value, I'll put 0. If they are not the same value, I'll put 1. Not the same value, I'll put 1. The same value, I'll put 0. Okay, but if you have three inputs, you may have to look at it slightly different. Although the explanation I'm going to give if you have three inputs is actually a more universal approach to look at it that would help you handle any kind of any number of inputs, including just two. So from two and above, of course, with this second explanation, it will be easy for you to understand. I have drawn this using logic.ly. Okay, so in case you have not used this very site, you should try and use it. It's very helpful. It has a lot of the gates for you to try. Okay, so these ones are for input, this for output, that's the logic gate, and even some electronic part, the flip-flops. Okay, so you may want to try this. It's very helpful. Okay, so I have drawn this, okay, with three input. So originally when you drag in your logic gates, especially the ones that can take two or more inputs, for instance the exclusive OR gate, you would have two inputs by default, so you can increase the number of inputs if you want. Yeah, you can. So that's by the way. Okay, so here we have with three inputs. So if you check, all of these are 0 0 0, right? So they are all off. Okay, so when they are all off, it will be 0, all 0 0. But if you have one of them on, it will be on. So one of them 1, it will be 1. So that means that what you're considering here is the number of ones. Is it an even number or an odd number? Okay, so in this case the number of ones is 0, and 0 is an even number. So when you have an even number of ones, this will remain off. Okay, but when you have the number of ones to be odd, this will be on. So 0 is an even number, so that's why you have this as 0 here. So let's do this as 1. You'll see this one is 1. And then if we choose to turn this off and make this 1, you see it's still on. Okay, and make this on, it's still on. So let me try to do with 2 ones. See, with 2 ones, it's going to go off. If I put this on and then this, you see. So but if I make it 3 ones, it's going to be on. So when the number of ones is an even number, this will be 0. If it is an odd number, this will be 1. And you remember that 0 is for off and 1 is for on. Thank you. Okay, so that explains the exclusive OR gate. So let's try to solve this problem now. Okay, so they say the B part here says consider the logic rules in the following table. A, so for 0, it is operator not present. For 1, operator present. For B, 0 is for ignition key present. 1 is for ignition key not present. See, now the same thing applies here. Okay, so the questioner says a crane is a machine with a long arm used to lift heavy objects. The crane will only move following these conditions here. If the operator is present, condition 1, and either the ignition key is present or the operator code is present. So take note that the operator being present is about A, the ignition is B, and the operator is C. Okay, all right. Meanwhile, we also need to take note of some of the keywords here. This is and then this or. So we need to take note of that. Very important. Now the crane moving is represented by S equals 1. So for this crane to move, S has to be equal to 1. Now write the logic expression for the crane moving. So write an expression that would result in the crane being 1. Yeah, true and true for the crane to be 1. Okay, so let's do justice to that question. Let's do this here first. So X will be equal to operator is present. So ordinarily operator is present is this one, where A will be equal to 1, which is operator is present. Operator is present. Okay. And then we have the AND gate. And then in bracket, because there are two conditions here, so we need to put them in bracket. In bracket, we can say, remember ignition key is present is B. Ignition key is present. So we'll say B, which in this case will give us 0. Or we can now say operator code. Operator code is correct, which is 0 here. So that's C equals 0. Now, if we truly do this way, we would realize that when we do or 0 and then AND it with the result of 1, this will give us 0. So it's not going to truly give us the one that we actually expect. Okay, take note that number 1, the output S equals 1 means that the crane moves. You right? Good. Then 2, the crane moves only when all required real world conditions evaluate to 1 following the conditions given. So for us to actually ensure that S will be equal to 1 for the crane to move, these conditions inside of here must result to 1. Since that is the case, that means for us to actually make this to be 1, we need to not this, we need to not this. Okay, and we need to leave this the way it is. So in that case, our S will be equal to A, and then you can open your bracket and you do your not B or not C. So that is going to give you the required results that you need. I hope the explanation is clear enough. So the next part is for us to complete the truth table for the crane moving. So we are now going to use this to complete this. Now the problem is, if you're wrong here, then the chances that you'll be wrong here, it's very high. In my usual way, I would like to use this working space because I think it's going to make the work a lot smoother for us. So what are we working with? Let's start from the inside of the bracket. We need our not B. Then apart from that, we need not C, and then we need not B or not C. Okay, let me quickly draw a line here. Okay, so let's do this as usual. So we are inversing all the values of the B. Okay, so here will be 1, here will be 1. Okay, so please do well to double check. So it's very important for you to double check. Okay, so let's do the same thing for C by noting all the values of C. Okay, so that's what we have now. Double check again just to be sure that everything is okay. Very important. Double checking. Okay, so it looks like we're good to go. So here we're now doing not B or not C. Okay, so this should be 1. Again, please do well to double check. Okay, so it looks like we're good to go. Now we need to do the final part. So with this final part, you are dealing with A and then not B or not C. So let's do that. Remember there is an and in between them. Okay, this will be 0. Okay, so with this I think we're good to go. Looks like everything is correct. Okay, so let's quickly check on the math scheme so that I can explain a few things here. Okay. Okay, so if you check on the math scheme, you will see that we're good to go. Okay, we're good at this point. Okay, so looking at number B question. All right, so you see what we have here. So you have 1 mark for this. That's the first part of the equation or the expression. And then 1 mark for this. So you can write this way, or you can simplify the expression by taking out the not gate outside. Okay, but when you're doing that, this needs to change to and. Okay, or you can use the NAND gate. So any of the approaches works. Okay, so this is what we did and it still works. All right, so this is the correct answer, complete answer, which is what we have, or any of these approaches that you want to take. So let's compare this last part. So you see yeah, 0 0 0 all the way. Okay, 1 1 then 0. Okay, so that means we're good to go. So if you did this like I did it, you should have the whole 8 marks in the bag already. I hope this video was instructive enough. I hope you learned something from it. Thank you for taking our time to watch this video. Please do also like, do also share, do also subscribe. That way this video gets to as many persons as possible. Okay, thank you guys. If you have any question that you want us to look at, any comments, please feel free to let us know, and in subsequent video we will attend to that. Thank you very much. I'll see you guys again in the next video. Bye for now.